Right, David Can here with another question from the question bank in the style of what you find in your Hayes and Harris textbook in chapter 10I.2. In this question, we're first asked to factorize the expression 3 sine squared of x take 11 sine of x plus 6. So really all we have to do is factorize. I have a squared term, a term to the first power, and a term to the 0 power. This is a pretty standard factorization, even if it's not immediately obvious what it should work out to be. So I'm going to wind up with two brackets. If I want to multiply two things together and get 3 sine of x squared, getting 3, there's only really one way to do it, multiplying 3 by 1. So I'm going to multiply 3 sine of x by 1 sine of x. If it's not 3 and 1, then this isn't going to factorize cleanly. 6, though, I have some choices. It can be either 1 and 6 or 2 and 3. And the choice isn't immediately clear because I'm trying to make 11. 3 times 6 gets me a little bit too high. That's 16. That's 18. That's too far away. 3 times 2 is only 1. Oh, sorry, 3 times 1 is 3. Plus 6 is 9. That's not quite 11 either. Let's see if we can work with 2 and 3. 3 times 3 is 9. That's almost there. Plus 2 is 11. I think I can do this with 2 and 3. So let's take 3, multiply it by negative 3 to make a negative 11, and we'll put a negative 2 on this side. What does this give me? Well, 3 times 1 is 3. Negative 2 times negative 3 is positive 6. So I've got my ends covered. What about the middle? 3 times negative 3 is negative 9. Negative 2 times 1 is negative 2. Negative 9 plus negative 2 is negative 11. This should work out. So that's part A. For part B, consider the equation 3 sine squared of x take 11 sine of x plus 6 is equal to 0. Well, hopefully one thing you notice is that this expression is the same as this expression, which is going to allow us to say that since this is true, then 3 sine of x take 2 plus sine of x take 3 is also equal to 0. Now, how does that help me making the substitution from the polynomial form to the factorized form? Well, it allows me to use the null factor law, which tells me that if two things are multiplied together, so here's one thing, and here's another thing, if two things are multiplied together and equal 0, then one or both must be 0. So therefore, 3 sine of x take 2 has to equal 0, and or sine of x take 3 has to equal 0. So one or both of them have to be 0. And now it just remains to solve these two equations for sine of x, because it says find two values for which sine of x satisfies the equation. So I don't need to solve it for x, just for sine of x. I'll add 2 to the other side and get 3 sine of x is equal to 2, and divide by 3. Sine of x is equal to 2/3. That's one value. The other one here, just add 3 to the other side. Sine of x is equal to 3. Two possible values. All right. Then in the last section, it says, now solve the equation for x. So take these two possible values for sine of x and find what values of x produce these values of sine of x and solve the equation. One thing to note is that we're working in degrees, not radians. The next thing to note is that we're asked, when is sine of x equal to 3? Well, we know from the unit circle that sine and cosine are never anything other than numbers between -1 and 1. So for this, there are no solutions for x. So we can throw that away. That's not going to give us a solution for x. We're only going to work with this one here. We're going to work with sine of x is equal to 2/3. To solve this for x, we'll take the inverse sine of 2/3. Now 2/3 is not one of the components of a major angle on the unit circle, so this is not something that you'll be expected to do in your head. You'll need to use your calculator to solve this. So let's pull up the calculator, and we'll pull up a new calculator page. And one thing we'll want to do is make sure that our settings are in degrees. So we'll go into Settings, Document Settings, and change the angle to degrees. Make that change, and we can go back to the page. And now we can take the inverse sine of 2/3. And what we find is that the result is 41.8 degrees. So x is equal to 41.8 degrees. And if you think you're done, be careful, because you're not. Anytime you're working with trigonometric functions and solving trigonometric functions, you need to stop and think, are there going to be multiple solutions? Because there often are. So let's see if there's going to be multiple solutions. We'll draw in the unit circle. Because remember, your calculator doesn't warn you about these multiple solutions. It just gives you the first one that it finds and says, yep, good enough. We want to know what angle has a vertical component of 2/3. Well, we know all the way up is 1, so 2/3 is probably about here. 2/3 is probably about here. So that's 2/3 of the way to the top. Actually, it looks a little bit more than 2/3, but we'll call it 2/3. 41.8 degrees is the result of this angle. But there is another angle that has a vertical component of 2/3. We find it if we go this way. This angle is also 41.8 degrees, but that's not how we express the angle. We express the angle from the positive x-axis. So the green unknown, which we'll call x2, so that's our solution x1, x2 is 180 degrees, take 41.8. 180 degrees, take 41.8 degrees, which gives us 138, that's a 7, 138.2 degrees. Those are both the solutions between 0 and 180 degrees. Of course, there are more if you keep going around, but we're restricted in our domain.